Hello students, welcome back to eGuru Learning. So today in this lecture we will talk about the trigonometric functions, and in the previous lecture we have already seen the two of the trigonometric functions, that is y equals to sin x and y equals to cos x. Now here we will talk about the rest of the trigonometric functions. Then after we will discuss some questions based on the domain and range of the trigonometric functions for jee-mains and jee-advance level. Now let us start with trigonometric functions. So the function that we need to start with is y equals to tan x. Okay, so first let us see the graph of y equals to tan of x. This is x-axis, this is y. Okay, now let's say this is pi by 2. And this is, let's say, 3 pi by 2. Okay, so the graph of y equals to tan x go like this. And here also this point is 0, this is minus pi, this is pi. Okay, so you can see that the graph of y equals to tan x goes from, this is the range of this graph is minus infinity to plus infinity. And talking about the domain of this graph, the graph is not defined at minus pi by 2, pi by 2, 3 pi by 2. So I can say that this graph is not defined at odd multiples of pi by 2. That means the domain of this graph would be r minus 2n plus 1 pi by 2. That means we need to subtract all these points where this graph is not defined. So this is the domain of the function. And talking about the range of this function, that will be all the real values. That means from minus infinity to plus infinity, the graph will take all the values. Okay, so this was about the graph y equals to tan of x. Now let us move to the graph of y equals to cotangent of x. So quickly we will see the graphs of trigonometric functions, then we will jump to the important questions based on these trigonometric functions, that is important from the point of jee-mains and advance. Now we will see y equals to cotangent of x. This is x, this is y. This is, let's say, pi, 2 pi, 0. And now let's see the graph of cotangent of x. This line, this vertical y-axis, will act as a vertical asymptote for this graph. Means, now let's talk about the domain of this function. So the domain of the function is all the real numbers except the points where this graph is not defined, that is 0, pi, 2 pi, minus pi. So domain of the function would be r minus n pi. Okay, and talking about the range of the function, that is all the real numbers from minus infinity to plus infinity. So this was about the graph of y equals to cotangent of x. Now let us see the graph of y equals to secant x. Now the third one is y equals to secant x. We know that the secant is reciprocal of cosine of x. Okay. First, let us draw the graph of cosine of x to draw the graph of secant x. Okay. So this graph here is like this. Okay, and here it would be like this. Now we will remove the graph of cosine x, and the rest of the graph that you will see is the graph of secant x. So this is the graph of secant x. Now talking about the domain of this function, so the domain of the function is all the real numbers minus those points where cosine x is 0, that is r minus 2n plus 1 pi by 2, odd multiples of pi by 2. And talking about the range of this function, range would be minus infinity to minus 1 union 1 to infinity. Okay, so this is about the range of the function from minus infinity to minus 1. This is minus infinity to minus 1. If I point this as minus 1, this would be the point plus 1. Okay, so from minus infinity to minus 1 and then 1 to infinity. So this is the range of the graph. Now let us quickly see the graph of y equals to cosecant of x. Fourth one is y equals to cosec x. This is x, this is y. Okay. Now to draw the graph of cosecant x, let us first draw the graph of cosine of x. Okay, now the inverted graph that is in blue, this will only touch here. Okay, now we will delete the graph in black, that is the graph of sin x we will delete. Now the graph that you are seeing on the board is the graph of y equals to cosecant x. Now talking about the domain of this function, so the domain is r minus n pi, where n belongs to the integer, and the range of the function will be again the same, minus infinity to minus 1 union 1 to infinity. So this is about the range of the function. Now let us quickly move to the questions on these graphs, okay, or the questions based on domain and range of these trigonometric functions. Okay, now so the very first question that we have is we need to find out the domain of the function. Find domain of y equals to 1 upon 1 plus 2 sin x. Okay, so to find out the domain of this function, we can say that the denominator part should not be equals to 0. So that means we need to remove all those points from the domain of sin x, and the domain of sin x we know is all real numbers. So we need to remove all those points where the denominator is becoming equals to 0. That means, let's say when 1 plus 2 sin x should not be equals to 0, because we say that the denominator cannot be equals to 0, otherwise the function won't be defined here. Okay, hence 2 sin x should not be equals to minus 1, and sin x should not be equals to minus half. Yes, so I need to remove all those points where sin x is equals to minus half. So the first point where sin x will become minus half first is, let's say this is minus half, so this will be the value, that is pi plus pi by 6. Hence this point will be x equals to 7 pi by 6. Okay, now if sin x is equals to sine of 7 pi by 6, so the general solution for this is x equals to n pi plus minus 1 to the power n into 7 pi by 6. So that means I need to remove all those points from the domain of the function. That means now the domain of the function will become equals to r minus n pi plus minus 1 to the power n 7 pi by 6, and where n should belongs to integer. So we need to remove all those points where this function is sin x is taking value equals to minus half. Okay, so the domain of the function would become equals to r minus all those points. So this was the very first question that I have to discuss here in this. Okay, now let us talk about the question number 2. Okay, so the question number 2 that we have on the screen is, find number of solutions of sin x equals to x by 10. Find number of solutions of the equation sin x equals to x by 10. So I need to find out the number of solution of this equation when sin x is equals to x by 10. That means I need to check where the graph of y equals to sin x and the graph of y equals to x by 10 meets in the real axis. So we know that, but first we need to check where we should check the graph are meeting. So sin x, we know that this lies between minus 1 to 1, and that means x by 10, because sin x is equals to x by 10 should also lie between minus 1 to 1. Hence we can say that we need to check for the values of x in between minus 10 to plus 10. Okay, because sin x is given us to equals to x by 10, so x by 10 is lying between minus 1 to 1, multiplying 10 both sides, so we are getting this region. Now let us plot the graph of y equals to sin x. Okay, so let us shift this graph to the some left hand side, because we need to draw this graph till 3 pi. Okay, so this is pi, 2 pi, 3 pi, and 3 pi, the value of pi we know that is 3.14. So 3 into 3.14 is 9.12. So this is 10. So we need to check the solutions in between minus 10 to 10. Let's say this is minus 10. Okay, let's move here. This is, let's say, minus 10. This is minus 3 pi, minus 2 pi, minus pi 0. Okay, now I need to plot the line y equals to x by 10. So we need to be very careful while drawing this line here. See, at x equals to 2 pi, that is 6 0.28, so the value will becomes 0.628, still it is lesser than 1. And at x equals to 3 pi, this is 0.9, so the value would be lesser. But from here the graph will go upwards like this. See, okay, so now we need to just check at how many points both of the graph, this is the graph of y equals to x by 10 and this is the graph of y equals to sin x. So to find out the number of solutions, the one solution is this, second is this one, third, fourth, fifth, sixth, seventh. So the number of solution in this case is now equals to 7. So the answer to this question would be 7. Okay, so I hope now you are pretty clear about how to get the number of solutions when you are given the equations like this. Now let us move quickly to the next question. So now the next question is, we need to find out the range of the function y equals to sine square x minus sin x plus 1. Find range of y equals to sine square x minus sin x plus 1. So we are interested in finding out the range of this function. So how to find out the range of these type of functions where this is a trigonometric function only. Okay, so now let's first write this equation as sin x minus 1 by 2 whole square. Completing the square method we are following. So this is sin square x plus 1 by 4 minus sin x. So we are adding 1 by 4. So we need to subtract also 1 by 4 from it. So this is 1 minus 1 by 4. And hence we will get sin x minus half whole square plus 3 by 4. Okay. So now let's find out the range of this function. We know that the range of sin x is from minus 1 to plus 1. Okay. So let's find out sin x minus half. So subtracting half from both the sides, so we will get half this side and this will become minus 3 by 4. Now squaring both sides. So on squaring both sides we will get sin x minus half whole square will be positive. That means this value will go from 0 till 9 by 4. Okay, now adding 3 by 4 to both the sides, so that is 3 by 4 and sin x minus half whole square, and this is plus 3 by 4 we have lesser than 9 by 4 plus 3 by 4, this is 12 by 4, that is 3 only. Hence a function, this was y, is going from 3 by 4 to 3. That means the range of this function, to write down the final answer, range of the function is from 3 by 4 till 3. So this is how we can find out the range of these type of functions where trigonometric functions are involved. Okay, now let us move quickly to the next question. Okay, so the question number 4 is, here we need to find out the range of another trigonometric function which is under the modulus, because the modulus functions we have studied in last class only. So find range of y equals to mod sin x plus mod cosine of x. Now to find out the range of these type of functions when both the functions are under the modulus function. So that means these are the positive values written over here. Okay. Now how to find out the range of these type of functions? Let's say we have y is mod sin x plus mod cos x. So if I squaring both sides, what I will get? Squaring both sides, I will get sin square x plus cos square x plus 2 sin x cos x. Hence that would become 1 plus sine 2x. Okay, and that 2 in the modulus. Okay, so we know that this sine 2x quantity can go from where to where? This maximum can take the value equals to 1. Yes, so y square, because we know that sine 2x can now take, because this is under the modulus, mod of 2 sin x and mod of 2 cos x, we can write this. Yes, and 1 plus sine 2x, that would take value from 1 to 2. That means y square will lie from 1 to 2, hence y will lie from 1 to under the root 2. That means this is the range of the function. Range is from 1 to under the root 2. So this is the final answer to this question. The range of the function is mod sin x plus mod cos x is 1 plus under root 1 to under root 2, both inclusive. That means it can be equals to 1 also, and it can be equals to root 2 also. Now let us move to another concept where we need to find out the range of the functions like a cos x plus b sin x. Okay, range of a cos x plus b sin x. So students, now we will talk about the range of the function of the type a cos x plus b sin x. Okay, so how to solve these type of ranges? So we will assume first a equals to, let's say, r cos alpha, and b will be equals to r sin alpha. Okay, now square and add both the quantities. So a square plus b square would become r square. R square cos square alpha plus r square sin square alpha is r square, and hence r will be equals to, as r square we know this is, so r will be equals to plus minus under the root a square plus b square. Okay, now let us convert this. Let's put a equals to r cos alpha here. So y will become r cos alpha into cos of x plus r sin alpha into sin of x. So let's take r common. We will get cos alpha. We have taken a as r cos alpha, so this will become, or if we want to make it, this now become cos of alpha minus x. Now we know that cos of alpha minus x will always lie between 1 to minus 1, minus 1 to 1, and r times cos of alpha minus x would be r to minus r. Hence we can say that this was our y, this is y will lie between plus root under a square plus b square to minus times root under a square plus b square. So this is how we can find out the range of the functions of the type a cos x plus b sin x. Now let us discuss one question based on this concept. So this is very good question from JEE Advance point of view. Now the question is, if we have given fx equals to pi by cos of pi by root 3 sin x and plus root under 2 by 3 pi cos of x. I need to find out the domain and range of this function. Okay, so to find out the domain and range of this function, clearly I can see that the domain of the function, there is no restriction on putting x to any value. So clearly we can say that the domain of the function would be minus infinity to plus infinity. Yeah, now the important part here is to find out the range of the function. Okay, now this is of the format a sin x plus b cos x, where a and b are given. So let us first find out the range of the function is, so A we have pi by root 3 here, B as root 2 by 3 pi. So we know that the range of this is, hence let's assume this value as t. So I can say that t would lie between root under a square plus b square to minus times root under a square plus b square, where a is pi by root 3 and b is root under 2 by 3 pi. So that would be pi square by 3 and this is pi square 2 by 3. Same here with negative times, pi square by 3 plus 2 by 3 pi square. Hence this is pi square, so this is pi minus pi. So we have t going from minus pi to pi. So I know that cos of minus pi to pi, let's see the graph of cos of x. So this is pi and this is minus pi. So we can say that the range of the function would going from minus 1 to 1. So cos of pi by 3 root 3 sin x plus root 2 by 3 pi cos x would lie between minus 1 to 1. Hence the range of the function would be minus 1 to 1. Okay, now let us move to the next question. So this was the question important from the JEE Advance point of view, and same is the question that we are taking now, that is the question 2 is find domain and range of again fx equals to logarithm base 2 mod of sin x plus 1. Okay, so this is the question in which we need to find out the domain of the function as well as the range of the function. So how to find out the domain and range of the function here? So what we will do is, we know that the domain of the function sin x would go from minus infinity to plus infinity. There is no doubt about this. Okay, now it is easy to tell the domain, but to find out the range of the function, so we know that the range of mod sin x would be from 0 to 1. So adding 1 to this, that would be from 1 to 2. That means the function, let's assume this value as t. This value t is varying from 1 to 2. Okay, now taking logarithm base 2 on all the sides. So as logarithm base 2 is an increasing function, hence this is my f of x. So fx will take values from 0 to 1. That means the range of the function will be from 0 to 1. Okay, so this is how we can find out the range and domain of functions involving trigonometric functions. So I hope students now you are pretty clear about how to get the domain and range of all the trigonometric functions and the functions related to trigonometric functions. Thank you students, and please do like and comment and share my eGuru Learning channel. Okay, thank you.